Service drop. The service drop is the overhead service conductors located between the utility electric supply system and the service point. The service point is the point of connection between the facilities of the service utility and the wiring at the house. The point of attachment of the overhead service conductors to a building or other structure should be not less than 10 feet or 3,048 millimeters above the finished grade. Overhead service. In many residential areas and practically all rural locations, the electrical supply is delivered to the property via overhead conductors strung on wooden utility poles. The high voltage lines connect directly to the property through a transformer delivering main power. While the service overhead belongs to the utility company, the inspector should still evaluate it, particularly to determine the available voltage, its clearances, and any mechanical damage. When the service drop is located above the eaves, the service mast or riser is run through the eaves. Underground service. When run underground from the utility pole to the electric meter, service conductors are installed in a buried conduit or run as the underground service entrance cable. The cable assembly. Most residential buildings are supplied with 120-240 volt services. This means that the cable assembly is made up of two ungrounded, live or hot conductors, each supplying 120 volts with one neutral or grounded conductor acting as the return. Many homeowners mistakenly believe that the three conductors include one each of a live, a neutral, and a ground. In fact, to have 240 volts available in the home, we need two separately derived 120-volt ungrounded conductors and a grounded conductor. The ground does not return to the pole through the cable assembly. The grounded conductor serves the role of the return path to the transformer. Each main service hot wire terminates at a breaker or fuse in the main disconnect, which is the first means of overcurrent protection. The main 240-volt disconnect is housed either in the base panel board or in its own separate box installed in combination with or near the meter base. The main service grounded or neutral conductor connects to the neutral bus bar. The location of the neutral bus bar varies depending on the panel manufacturer. It is a silver-colored bar with many small holes and screws and one larger hole for the main service grounded neutral wire. There are, however, a few variations on the theme. It is not unusual to see one of the live conductors tied back. This is indicative of a 120-volt only supply, which is still installed in some older properties, apartments, and condos. Conversely, the inspector may see cable assemblies with more than 3 connected conductors. This is typically a 3-phase supply commonly found in both commercial and agricultural environments. In the case of 120-volt only supply, we recommend that the inspector's report shows this limitation. In the case of high-voltage, 3-phase supplies, we recommend that the inspector defers this part of the electrical inspection to a qualified industrial or commercial electrical contractor. Service cable connections. Point of attachment to the building or structure. A typical 3-wire service drop consists of 2 insulated hot conductors wrapped around a bare, stranded aluminum wire with an internal steel messenger cable. The bare aluminum wire also serves as a neutral. On some older properties, the conductors are not in an assembly and each has its own connection to the structure, but this is rare these days and probably in need of replacement. The point of attachment of the service drop conductors to a building or structure must have clearance above the finished grade of at least 10 feet. The overhead service must have some minimum separation from both the structure itself and any walkways, driveways, balconies, patios, and swimming pools. Very often, an inspector will see properties that have been modified and the service overhead should have been relocated but wasn't. This can obviously lead to some dangerous conditions, especially over swimming pools and decks where the service connections could be accidentally reached by the homeowner. Service drop clearances. Over public streets, roads, alleys, and parking areas with truck traffic, the minimum clearance requirement is 18 feet. Over commercial parking areas, the minimum clearance requirement is also 18 feet. Over swimming pools, the minimum clearance requirement is 22 feet and 6 inches above and 10 feet horizontally. Over residential properties, yards, driveways, and any other parking areas, the minimum clearance requirement is 12 feet. Over all walking areas, sidewalks, decks, roof surfaces, and patios used by pedestrians only, measured from final grade or other accessible surfaces, the minimum clearance requirement is 10 feet at the electrical service entrance at the lowest point of the drip loop. Above roof surfaces having a slope of less than 4 12 and not subject to pedestrian traffic, the minimum clearance requirement is 8 feet maintained for a distance of at least 3 feet in all directions from the edge of the roof. Over roof surfaces having a slope of 4 12 or greater, the minimum clearance requirement is 3 feet. Over roof surfaces where voltage is 300 or less and the roof area is guarded or isolated, the minimum clearance requirement is 3 feet. Termination of through-the-roof raceway or approved support above the overhanging portion of the roof that is less than 4 feet measured horizontally 18 inches from sides of doors, porches, decks, stairs, ladders, fire escapes, and balconies, and from the sides and bottom of windows that open 3 feet from the bottom, sides, and front. Refer to 2021 IRC E3604.2.1 above roofs. Conductors must have a vertical clearance of at least 8 feet above the roof surface with a distance of at least 3 feet in all directions from the roof's edge. There is an exception for low-sloped roofs or flat roofs with a surface accessible to pedestrians, such as a balcony or deck. Overhead service conductors supported on and cabled together with a grounded bare messenger wire above a roof surface subject to pedestrian traffic must have a vertical clearance from the roof surface of at least 10 feet. The minimum vertical clearance must be at least 10 feet at the electric service entrance to buildings, at the lowest point of the drip loop of the building electric entrance, and above areas or sidewalks accessed by pedestrians only. Such clearance shall be measured from the final grade or other accessible surfaces, such as deck or balcony surface. If it's just a flat roof with no pedestrian access, then the clearance is 8 feet. Another common clearance problem is caused by trees and shrubs interfering with the overhead supply. The inspector should take the time to eyeball the length of the supply from the pole to the attachment point on the structure and report any tree limbs touching the conductors. Also, remember that the branches are heavier during the summer and weigh down further on the conductors. What may be marginal during the winter months may well cause a problem later in the growing season. The inspector should recommend that any limbs within 5 to 6 feet of the cable assembly be cut back.